Welcome to the Rotating Polygons on a Grid tutorial with a focus on the basic transform rotate. In this video, we will be using Rhino and Grasshopper to create a regular pattern of polygons of varying types and sizes, which are progressively rotated over a gridded field. In this tutorial, you will learn about Grasshopper's square grid component, creating and using a series of numbers, and using the rotate transform. So to get started, we are going to draw a square grid, about 10 by 10, should be fine to get us started. And we can find the component that creates a grid up here at the top under the fourth tab under vector, and then the second sub-tab grid, and we'll find our square grid amongst other options. Alternatively, and more commonly, you could just double click the canvas and just start typing square grid, and we see this pops up. So square, and we see the icon for the grid, and we could just click that, and our square grid component has now come to the canvas. We also see that it is here in the Rhino, so it's been populated into Rhino. And if you can't find that, you might just be in the wrong place, so just make sure to zoom in to where that appears. So I wanted this to be 10 by 10, so I'm going to set up two numeric sliders. And to do that, I can, again, come up here under parameters, input, number slider, and then just drop that on. Or I can double click and type slider to get that as well. So I'm going to enter into my slider to change the variables, because see, this slider only goes between 0 and 1 and it has 3 decimal points of precision. And for a square grid, our extents x and y, these need to be whole numbers and need to be greater than 0. So I'm going to double click here on slider, and this brings up the properties of our slider. I'm going to come here, slider accuracy. I'm going to set this to the second option, integer numbers. So these are whole numbers. And I'm going to make my minimum 1. So I want at least 1 in every direction. And for now, I'll make the maximum 20. I can change that later if I need to, but that should get me started. And then when I click, hold down, and drag to the component input EX, extents X, you'll see that this has automatically renamed that number slider to extent X. And if I drag this up to 10, you'll see that now I have 10 cells in the X direction. I'm just going to copy this, Control C, Control V, and I'm going to plug this one into extents Y. And now I have 2 sliders, and I have a 10 by 10 grid. Now I don't really want the outlines of the grid. What I really want are the center points, and from the center points I'm going to be drawing my polygons in the next step. And so to get the center points of a cell, we have 2 outputs from the square grid. We have cells and points. The points are actually the corner points. So if I use this, I'll actually get 11 points in the X and Y direction. So you could do that, but we're not going to. And so, but what I'm going to do is I'm going to use the area component. So this is what we use for finding center points, confusingly enough. So just double click and type area. And this will drop a component onto the canvas, which needs a geometry input. And the geometry we're going to input are our cells. So left click, hold down, and then just drag the wire into area. So now I have my center points of the cells, and I'm going to go ahead and turn off the preview for the square grid by right clicking and hitting preview. And so now I have a 10 by 10 grid of points. So once I have my 10 by 10 grid of points, doesn't need to be 10 by 10, but that's what we're going to use. What we're going to do is we're going to draw a polygon at each one of the points. And the component we're going to use is the polygon component. And the place where you find this is under the 5th tab up here, curves, primitive, and it's under here, just down here towards the bottom, polygon. I rarely use these tabs, but I'm just showing you in case you need to know. So let's just double click and just start typing polygon, and the component drops onto the canvas. You'll see here it's drawn a hexagon at the world origin right here. That's not what we want. So what we want to do is we want to take these center points, the centroids, and we want to put them into this P input, which is the base plane or the kind of the origin of each one of our polygons. So we'll just left click, drag, drop it in. And you'll see it's gotten quite busy. And the reason why is because our grid extents, there's only one unit in each direction, and our polygons are much bigger than 1 unit wide. To see exactly, if I hover my mouse over this R input, we can see the radius here has been input at 3. So we're going to want a much smaller radius than this. The other alternative is we could come back here to the grid cell size and drop a number slider. Another way you could drop a slider is double click the canvas and just type a number kind of in the range you want. So if I just type 5, push enter, what that has done is it's automatically created a slider between 0 and 10. And since I just typed the number 5, it's automatically made that an integer. If I came up here and I typed 5.0, it would make a slider with floating numbers with 1 point of accuracy. And if I typed 5.00, 2 point accuracy. So that's just a handy trick. You probably already know it. If you didn't, then now you know. So I could come to here and just drop that into there, and you'll see that this has changed my grid to a 5x5 grid. The other alternative is to add a slider to the radius, and that's what we're going to do. And I'm just going to type the number 1.25 here, which is giving me a slider between 0 and 10 again, with 2 point accuracy. And now I can modify my polygons. What are some of the other options on polygons to play with? The number of segments or sides. This is a number between 3 and whatever. And I'm just going to plug that into the S. And you'll notice if I go under 3, this has turned orange, which is creating a default an error state, because you can't have a 2-sided polygon or 1-sided or a 0-sided polygon. So 3 is going to be the minimum. So I'm just, to prevent any errors in the future, I'm going to come in here and I'm going to change that minimum value to 3. And we'll make my max a duodecagon 12. So 3 and 12, squares, pentagons, hexagons, heptagons, octagons, sorry, nonagons, decagons. I'm not sure what 11agons are, and duodecagons. So let's just go down to 5 pentagons, and that's what we'll use going forward with the rest of this. The last option here is the fillet radius, which we'll be able to round off your edges. I'm just going to type the number 0.25, and this has created a slider between 0 and 1. And what this will do is, you could see, as I increase this, it will round those edges. Let me just go down to a triangles here, and you can maybe see that a little bit clearer, how it kind of rounds those edges off. So let's just keep that one on, and let's go back to our pentagons, and we'll have slightly rounded edges, but not too much. Our third step will contain the core logic of this particular example. So we have our grid, we have our polygons, and now what we want to do is we want to rotate these polygons in a sequence. So we have my polygons, and what I want to do is I want to rotate them. So I'm going to use the command rotate. This is what's called a transformation, and the transformations are found under the 4th, 5th, 6th, 7th, 8th, the 9th tab, which is transforms. And the basic transforms are here under Euclidean, mirror, move, orient, rotate 3D. So we're going to pick this one, rotate, an object in a plane. I could also just double click and type rotate on the canvas to get that. So what do we want to rotate? We want to rotate our polygons. So I'm going to click and drag a wire from the polygons output into the geometry input on rotate, and we have our rotation set up. Now it didn't do what we wanted. You can see here we have the polygons appearing here to the left, and what's happened is it's rotated all of these polygons around this point, which is the world origin 0, 0. So it rotated them 90 degrees all together. So that's not what we want. We want each polygon rotating around its own center point. So the second input, it's actually the third one, but the second one we're going to talk about is the P input, which is the plane, the rotation plane. And the rotation plane is, you can think of it as an individual subplane that each individual polygon is rotated around. So the rotation plane is going to be our center points. So we can drag a wire from our center into the P input, and now it is rotating each individual polygon around its own center point. Now you can see here it's a bit hard to see the wire. There's a few different ways you could fix this. You can double click the wire and this relay object will come out, and you can add a few of these just to start to clean up your script to kind of control how the wires are going. Alternatively, you could drop in a point parameter container. This is usually what I do, and have these feed into there. Let's just copy that and paste it, feed into there, and then into there. I'm going to right click this and hide this. Hide, let's turn the preview off for these, and I'm going to go ahead and turn this preview off as well. We'll turn this one on. Usually you only want the last example to be on. So those are two alternative ways you could kind of clean up that wire. So now we're rotating around the individual center points, and you can see each one though has rotated the same amount. And if I turn off these polygons, you can see, well, you really can't see how much it's rotated, but let's turn them back on. But they've rotated this angle amount. So what I want to happen here is I want each row to have successively more rotation than the previous row. So what I'm going to do is I'm going to input a series component. So I'm just going to double click and type series. The series component itself, I'm not sure exactly where it's found. Maybe it's here under set. Yes, set, the third one, the second sub-tab sequence, and we have series range, series, etc. So our series, the first number is going to be 0, so that means our first rotation will be 0, and then we could change that to the first rotation being something more. The step size is each successive number, how much it's going to be rotated. So I want each polygon to be rotated 15 degrees more than the previous one. So I'm going to add a slider with 15 in it and put that into there. And the final input on the series component is the count, how many values I have. The default is 10, which conveniently is the same as our number of rows, 10. let's just change this here to make this a 3 by 5. It'll be a bit easier to see, but also you'll see, so now I have 3 rows, 3 columns, and 5 rows. But the count is still going to be 10, and so I have this series. I can drop a panel here just to see what the series looks like. So 0, 15, 30, 45, 60, 75, 90, 105, blah, blah, blah. And if I input this into the angles, you'll see that it's rotating these in the series, but then the last polygon gets rotated all the rest of the values. So the first one is 15, second one is 30, third row is 45, the next row is 60, and then the final row gets rotated 75, 90, 105, 120, 135, because we have too many values here. So a handy way to fix this problem is to measure how many polygons we have using the component called list length. And I'm just going to double click on the canvas and type list length. It's right here. And that's also here under the third tab at the top, set, list, and list length. So if I measure my polygons, and let's just look at the list length here. So my first column, and this has a data structure, we'll talk about that in the next video, but each column has 5 individual elements. And so if I plug this into the count, you'll notice that now my series 0 to 60 is limited. And if I come back here and if I change this value to 6, let's say, you'll see here now that I have 6 values for my rotation. There's a final problem here, and that's our unit conversion. So here under the angle, it's asking for a rotation angle in radians, and so 15 radians. What we want is 15 degrees. So there are 2 ways to do that. The simplest way is to right-click the A and then change this input to degrees. Alternatively, we could use a component called radians. Double-click and type radians, and this will convert a value in degrees to radians. And so 15 degrees is 0.261799 radians. So that's maybe a bit cleaner. So let's just take the degrees off and we'll plug that in as well. So simplest form is just to change this input to degrees, but you could also use that component there. So now we can see that we have our successive rotations. I'm going to actually change the number of sides of my polygons to 4. It's a bit easier to see with squares, and I'm going to turn the preview for this off. And you can see our first is a diamond square. This one is rotated 15 degrees. The next one is rotated 30 degrees from this, or 15 more than that, 45 degrees, 60 degrees, etc. So that's the core logic of this. Now you can see here it's rotating everything in the rows the same. That has to do with the data structure, which I'll talk about in a subsequent video, in which you could also read about more on the blog. So the core logic of our script has been set up, so we're just going to do one final simple step just to improve the display of these polygons just a little bit. So what we're going to do is we're going to add a surface to each one of these shapes. So here under the 6th tab, surfaces, freeform, we have this boundary surfaces component. Again, you could just type that in if you prefer. And we'll just drag a wire from our geometry output into our edges input. And it's added this, this is the default color in Grasshopper, is this light red color, pinkish color. And so we want to change that. And so what we're going to use is a component called custom preview. So here under display, preview, we have the custom preview component, and we'll just drop that down in. And you can see there's no color here. That's because our material also needs to be set. And here under the first tab, under primitives input, we have what's called a color swatch. You can also just double click and type swatch on the canvas. So let's just drop that in. So it's set to white right now. Just click that and we'll just change that to maybe something yellowish, like the example which is on the blog. So that's basically it. We can come back and we can start playing with some of the parameters. So let's get back to a 10 by 10 grid. Now let's do like a 10 by, let's get a bit taller. 10 by 13. And we can also play around with things like the radius, the angle of rotation. So 100 degrees, let's just get, that's 0. And I'm going to turn those off right there. And so that's about it. So you can, when you play around with the parameters, you can see that sometimes some different kinds of interesting patterns will emerge. We can play around with the number of segments. And yeah, so that's the example. So one final thing before we move into the next video where we'll talk about the data structures. Often I like to take my parameters, right click and click group and color them, and I will usually color them red for an input parameter. So these are the things that you can change in each script, and I just like to give them this red color just so I know, and also to rename them. So this step is our series, and so this is actually, let's rename this the rotation amount of rotation in series. Right click that. You can put a single item into a group and give that a, it's a bit hard to do this sometimes, color red. And those are the parameters that I can now change. There's a few other things you could do. You can group different operations together which are logically connected, and I will usually give these like a gray color. Different groups, and once you have a group you can right click this and you can give it a name. Creates a grid of points with cell centers. So, and let's just put a 1 there, so that's step 1. So that's one thing I like to do, just to kind of let myself know later when I open up a script later what's going on. So in the next video I will explain briefly a little bit about data structures, but just as a preview, if I take these cells here and I flatten them, let's just go back to our polygons and let's make these 4-sided. And let's increase the amount of rotation to 16. So you can see here that these subsequent angles are applied to each row, but each item in each row has the exact same rotation. If I come out here and I take my center points and I flatten that, you can see something different happening, but basically what's happening is the series of rotations is going up each item in this row, and then the rotations continue in the next column the next column, etc. And if I look at the panel, you can see these are the angles. The final item is rotated 2,000 degrees, so it's just spinning around. So I'll talk a little bit in the next video about that, and as an introduction to some ideas about data structures. Okay, see you then. So on my blog, I've explained how to set up the example rotating polygons on a grid, and you have everything you need to know to get this pattern generator as I've set it up here. But if you would like access to the completed version of this script to save yourself time, or also just to support this blog and the work that I do here, then consider purchasing downloading the completed version of this script from my blog, generative-landscapes at generative-landscapes.com. And it's just a very small amount of money, but it will definitely help support me in developing further content on this blog. So there's a version which is basically a cleaned up version of the script as it's explained in the blog, and then as a bonus there is a second version with some added functionality. So I'm just going to turn this version off, and I'm going to turn this version on. And the added functionality isn't really that much, but you can change the output type to, for example, edge curves, flat surfaces, or extrusions. Let's just look at the perspective view to see what these extrusions look like, and you can change the height of those. So that just saves a little bit of time. Or you can also change the data structure here. So I've explained in another video how to change the data structure, but you can change this to flattened data, normal data, or grafted data, and it will automatically select one of those three data structures. And you can also draw a point in Rhino to change where your script starts. So if I clear that value and then I set a point, you can have your script start in a new place. So yeah, so if you would like to consider downloading that and purchasing that, please go to my blog, generative-landscapes.com.